Hi, welcome to the course. My name is Fuad, and this video series will help you understand your reading material, assessment, and health professions education. Now, I'll point out to you in this series what's important, what's not so important. So, let's go right to it. Bismillahirrahmanirrahim. Hi, and welcome to our third class. And the reading for this class is the third chapter, which is reliability. Now, before we start, please remember that if a test is valid, then you would expect it to be somewhat reliable. And if a test is reliable, it supports the validity, but being reliable in itself does not necessarily mean that it's valid. Okay, a test can be reliable but not valid. You have to remember that. However, if looked at the big picture, you have other evidence supporting a validity of a test, and one of those is the reliability of that test. Okay, so introduction wise, the author refers to the consistency of scores. That is the classical definition of reliability. Consistency of scores or decisions for assessment. Okay, so it gives the example of in lay terms, what does reliable, he is a very reliable person. This machine is very reliable, meaning that you can depend on the person or the machine. So if we say a test is reliable, you can depend on it, meaning that it is consistent. That if a person, you use the test to measure an attribute for that person, then if you theoretically, if you do it again and again and again, you would get consistent results. It's dependable, it is reliable. Okay, that's what it means. So the author in page 33 begins with introducing classical test theory. Now, classical test theory is the theory upon which a lot of the discussion about reliability, the formulas, and all those things are based upon. Okay, and therefore this class is quite straightforward. It introduces concepts, formulas, so I will not be explaining to you much because it's straightforward. However, I will point out uh, the emphasis on applications and how to use these concepts of reliability. Okay, so I would hope that you would read through the chapter, especially if you're interested in the formulas. I do not expect you to remember complicated formulas, all right? But it will be of a good stead to you if you can understand the theory behind it. Now, classical test theory, it says here, it forms the basis for reliability estimations. Okay, so using classical test theory or CTT, we describe common test-based reliability indices: test-retest reliability, split half reliability, and internal consistency reliability, or Cronbach alpha. We will discuss more of that later. And also reliability between raters. Okay, the test retest, split half, and internal consistency refers to the classical or paper-based examinations, MCQs, and things like that. But especially in health professions education, we also talk about examinations or assessments like OSCE, like long cases, where we depend on raters to get the data, get the scores, get the results. So we also talk about reliability in these situations, and it is discussed here. We discuss about reliability in these situations. We'll talk about exact agreement, kappa, and intra-class correlations. Okay, so we go on to the uh, next page, where it explains further about the importance of reliability. Please go through that. Please go through them. And then the author goes on to give a theoretical framework for reliability. It gives a good analogy about true scores and error. Okay, so it gives a nice illustration in the analogy where it talks about you and your friend are having a video conference. So reliability is the proportion of the true score over the true score plus the error. That's the basis, that's the whole basis of reliability calculation. Okay, so it goes on to explain in more detail classical test theory. I do not expect you to remember the exact formulas, but an understanding of this will go to great lengths to help you understand how we calculate and how we regard reliability in the scheme of things. Okay, so in the explanation it says again here, observed score, what the score that we get, paper-based assessments or observer-based assessments, you will get a score. So that score, we assume it is composed of a true score and error. So let's say I get 76 for my MCQ paper. So that 76, part of it is based on my attribute, whatever attribute that the test is measuring. But part of the marks, I might get lucky. I do not know, but I guess, for example, and I get a score for that, the correct score. So part of that 76 is from error. Okay, I might not understand the questions, so I get less than I should have got. So again, observed score or obtained score is equals the true score plus the error, and from that it goes on to explain. It gives you an illustrative example of the concept of reliability based on or as discussed using the classical test theory. Right, so implications in CTT, systematic variation is solely attributable to differences in true scores. So if scores are going up and down as you repeat the tests, it is in CTT we assume that these variations, the scores going up and down, is totally due to the error. What is constant inside there is the true score. However, he's saying that actually sometimes error can be part of that constant component, which is what we call as a systematic error. Okay, so it gives you chapter 2 provides a comprehensive discussion, blah blah blah. Chapter 7 and 12, well, just be aware of this issue. Okay,